So, okay, so welcome everyone. We have 7 online right now to Dallas Personal Robotics Group's first attempt at a virtual robot builders night out. I'm Carl Ott, current president. We have, I think, a lot of past presidents and a visitor from Colorado and someone calling in on the phone. So, could I get who's ending with the phone in 78? Could briefly you identify yourself?
I think that's Clay.
That's Clay. All right. Okay. So, all right. Well, we might have more people come in, but the idea here was just as we're all stuck at home, I hope everybody's safe and sound. No family members caught up in this disaster that's unfolding.
Not yet.
Yeah. My wife works at Medical City, so I'm trying to prevent catching it and sharing it.
Do you screen her before you let her in? Check her temperature?
No, but she got gas on the way home, so she went to great lengths to wash her steering wheel and her phone and such. But
oh, that's good.
yeah. So anyhow, the idea was to just keep the DPRG kind of discussions and interaction going while we're stuck at home. Maybe make it easier for people who could jump on that don't normally get to attend. So welcome, Alan. And tonight the idea was just to kind of do a round table where maybe we go around table, everybody just spends a few minutes talking about whatever project they're going on while they're stuck at home. And then I'm set up to demonstrate using Visual Studio Code with the Arduino and Git. Just a kind of an ad hoc presentation. So I can talk about my projects when we get around to my part. So we just go down the list. And like Alan, you're first if you're comfortable. Do you have any anything you're working on now that you're newly retired and stuck at home in Colorado? Alan? Okay, let's move on. So Clay, you're stuck at home, I guess, and line follower guy still?
Yes, I have been working on my robot. I'm able now to record all the frames at full speed and then assemble all the images into a movie. So I've made a short movie of a run on part of the advanced course. And that's working well.
Oh, that's cool. That's cool. All right. And then Ray, I see your robot. You showed your robot in the background. Is that your main thing?
No, that's it's been here for a while. I put a little too much voltage in on the converter, and it's kind of weird. It took a little, I think it's a 1117. It's a linear regulator. It takes it about 5 minutes to fail, so it was a little difficult to to figure out. But it would like slowly drop down in voltage. I've got like a strip of 20 coming in, so I can replace it. And I've got went to Micro Center and got some more. They were on sale, the megas. Yeah, that's the grass is getting taller outside. The days are sunnier, so I'm gonna have to get it outside and put it to work. But what I have been working on, I've been trying to just use, kind of get into, using 32-bit processors. This one is it's the blue pill, so it's the, I don't know if let's see, yeah, you can see it there.
You want to share your screen?
Yeah. Do I have to do that, or
maybe I need to stop sharing?
Oh, okay.
I'm presenting, so how do I stop presenting? Click the stop presenting button.
There you go. Okay. If Ray wants to present, he's just got to hit the present button down there.
Yeah. Aha, present now. your entire screen. How about a window? Okay.
Ah,
I don't see myself, but you don't get to see yourself when you do that. Anyway, so it's the blue pill, the STM32F103. It's just kind of a thing getting used to the STM Cube IDE. Basically, I had interrupts for the encoders before. Now I don't need interrupts at all. I'm using 2 channels of timer 1 to generate PWM for the motors. I'm using timers 2 and 3 to read the encoders, because you have to, it's pretty much 1 encoder per timer. And then timer 4, which in this version there's only 4 timers, is used for at least 2 channels of for servos, because they have the 50 hertz period, and a little bit different timing than the other motors. So I kind of wanted them independent. So that's kind of nice. I've got there's a little color display, and the color display is SPI, and then the monochrome display is I2C. They're both 80 by 160. Pretty small, but you can get a fair amount of text on it. A lot more than the little character displays. So I've gotten both of those working with Arduino, but not with using the Arduino IDE code for that. But not basically you have to kind of port everything. There's not really anything done for okay, I take that back. A lot of individuals have contributed, and you can pull whatever they've done in off of GitHub and give it a try and see if it works.
yeah.
Some of them are successful, some are not so successful, but I haven't gotten the 2 to work under the IDE, the STM-Cube IDE yet, but they do work with the Arduino IDE. There's examples. Adafruit has them for her displays and stuff. So purchased 2 of the STM32F 401 boards. They're similar in form factor to the blue pill. It's a 40-pin dual inline. It's kind of like the blue pill. You can get different package sizes with different pinouts and different functionality. Different flash and SRAM sizes, all that kind of stuff. Same thing with the 401. But it's the smaller package, because you only have 40 pins, so it's a little bit limited. Anyway, so that's what I've been working on, trying to get that up and going. And once you kind of get used to the STM32 Cube IDE, it takes very little code to get things to work, and basically once you kick off all those timers, they'll run forever pretty much. So
Neat. Yeah.
Anyway, so that's what I've been working on.
Well, that'll keep you busy. That's
Yep.
cool.
Yep.
Steve, how about you in your safe shed in the woods area back there?
My shed in the woods out in the country. Well, as you know, I'm not really working on too many personal robotics things right at the moment, but still helping Omar with the Dragon board running Windows 10 IoT, and we're trying to get some machine learning things, and also some FFmpeg streaming video up to the cloud to Azure. And
Nice.
so I've been helping him with the FFmpeg and the .NET Core application services that are running. That's going to be the core of his robot, that rolling ball thing.
Yeah.
So we've been working on that, getting that to work. We've got several of the sensor drivers, motor drivers, and things working now, and integrated, checked into the GitHub that we're working on. And my next task is just to get this streaming thing to work, but I haven't had a lot of time to work on it recently. So,
Have you been busy keeping servers running as Microsoft gets overloaded with Teams and stuff?
yeah, we're very busy right now. I don't touch anything with Teams. I have to use it, but that's not my product. But my product, the customers are quite busy keeping their businesses running, scaling everything up. So busy.
Got to be a crazy time.
Yeah.
So is Omar still calling his thing Obi or Orbi?
No, that name was already used under copyright, so it's now called Romball.
Romball.
ROMBALL. Yeah.
Okay. Yeah. So Alan, one of our members has been working on this Kickstarter project for a couple of years, and it's Steve could probably describe it better, but it's basically a ball that you can drive around and roll remotely, and it's got camera in there. And
right, it's like a
very cool.
Yeah, it's kind of like the toy ball that you can control with your phone, except for this is more intended to be like a home security device that you can roll around your house while you're away and go into different rooms, interact with your pets, and they're also looking at a commercial implementation to deploy in large warehouses for roaming security, and they can pre-program the paths, and the machine learning looks for people and or certain recognize certain objects, and listen for certain types of sounds that are like intruder breaking a window and that kind of stuff.
Mm.
Wow, that sounds really neat.
It'd be a pretty cool project once it's all working.
Yeah.
What do we search on for? Is it visible on the web yet?
I think he has a website for it. Romball. ROMBALL.
There's one based in. Yeah, yeah. Doesn't look good. He's got to own that term. He's got to own his own name on Google search. He doesn't at the moment.
Not yet. No.
Not yet. Okay. So Alan, how about you? Are you pursuing robotics projects? You thinking to get into one or?
Oh.
Audio's not working so well. Alan, we're not catching your. Oh, there we go. Sounds like a microphone connection problem.
Okay.
There we go.
How are we doing?
Oh, that's perfect. Yeah.
Oh, good. Yeah, no, I've just been building odds and ends mostly, and I work with a bunch of robot teams in California and Colorado. So.
You mean commercial ones or kids fun ones?
Yeah, the kids, mostly the high school.
Oh, like FIRST and FFL and those kind of robot
Yeah,
leagues?
exactly. FLL, all those guys. Yeah. So I've been doing that, and I also do science fairs, but those all got canceled this year except for the Colorado one, amazingly. So I'll be doing the engineering section, judging the engineering section of the local science fair here.
That's cool.
In a few weeks. So
yeah.
They haven't canceled all those.
No, they
schools
figured
up
out
there
how
yet?
to connect us on the web, just like you guys are. So that's how we're going to run the science fair. They'll show their board. I'll see the kid talking. We'll interact with him as judges, and we'll let them win that way. Everybody else, the California and the international science fairs, have sort of dropped out for the year.
Huh.
So Colorado.
Well, I'm glad to hear it.
Yeah. So Colorado's doing good. They jumped right on it and switched their mode of operation, and they're running with it.
So what?
Should be good.
Fantastic.
What's the coronavirus situation in Colorado like?
It's the same as every. I think we have. It just kicked in maybe a week and a half ago, and started, and it's driven up from there.
Yeah.
I think we have 100 and some confirmed cases, and I think we're up to like 6 fatalities now. So, and we're basically under house arrest. Not quite that bad, but you know, we can go out and run around, but you know, you gotta have your distance rules and all that kind of stuff going on.
Yeah, same thing for us.
Yeah, so
I think,
we just sort of you fall back on your hobbies, I guess, to keep it going.
Right. Yep.
And the honeydew.
Oh, that's good.
What's that?
I said, and the honeydew list.
Oh yeah, that's never ending.
Yeah.
Ray has a long honeydew list apparently, so.
I don't know if I'll ever finish it.
No.
Yeah.
It's by design, Ray.
Probably, yeah.
Yeah, so we have one of the club members, or a couple of them coach. Is it First Teams or is it?
Yeah, it's First Robotics.
First
here.
Robotics. So
Yeah.
if you search for Iron Rain, you'll that's here in Dallas. We interact with them a lot.
Oh, okay. I have to check it out.
Yeah.
Yeah, I don't know what Pat's team is called, but they're also very highly rated team.
Yeah, I think we had just neared the end. We were within, you know, we'd completed all our local matches, and then we came up on the, you know, the national version, and everything got froze.
Yeah.
Everything got shut down. Yeah. So.
Yep. All right.
There's Jack.
Hey, welcome aboard, Jack. So, Jack, we have Alan from Colorado, and then some of the usuals here in town, and Jack is now in, I guess you could say in college, but he's out of college because college is closed. So, hey, Jack, I think you're on mute. Did you want to just we were going around, and do you want to take a couple of moments and describe what project you're working on? Except you're muted, so we're not hearing anything.
Oh, there we go.
Oh, there you go.
All right, so I was just working on the 6-can competition, although I think it's can soccer, right? That's for this upcoming competition.
Yeah.
Okay, and I keep burning out my Arduino boards. So
Yeah.
yeah.
Yeah, I saw that traffic you had with Doug, and if you like what we could do after we get through this presentations and stuff, we can maybe try and talk you through and diagnose if that'll help.
Oh yeah, that would be nice. Thank you.
Yeah. Didn't you switch out the regulator? It's a 1117. It's a little surface mount part.
Yeah, I did.
Yep. Yeah, I found, well, you can't really draw that much current out of them. It'd be better if they would just, you know, well, I'm trying to think who did that. I think Adafruit did it with one of their Metro boards, actually put in a switching regulator that tolerates higher voltages than it does. I think if you, like in my case, I used a lead acid battery, and when it's charging, it's up to like 14.25 volts, and if you draw any current out of it, it just tends to fry it. It just, you know, you can't get that much current out of a linear regulator, so that may be what's going on again.
So I've just got too much of a demand that I'm from the Mega.
Yeah. Are you running like a Pixie Cam off it?
Yeah. Actually, it was right when I plugged in the Pixie Cam that it burnt.
Yep. Yeah. That's what I found when when it's just kind of idling, not doing anything. But if I flash a can in front of it, that's what kills it, and it's just a little bit too much current demand at a high voltage. And it's just, you know, forcing it to dissipate a little too much power, and poof it goes typically. But mine, it kind of like, it takes a few minutes for it to actually fail. It'll work for a little while, and then I'm not running the high voltage in it anymore. But I think I just stressed it too much.
Oh, okay.
So yeah.
Let's help you towards the end. We'll see if we can't look at the specs. We'll look at the specs and kind of do a power budget for you. Help you with that.
Okay, thanks. Yeah.
And that might and then see what equipment you have, and then you can verify it and such.
Okay.
All right. So maybe shall I go next then?
Sure.
So, and then I can slide on into the Git thing I was gonna, or the Visual Studio Code stuff I was gonna do. So basically, I'm sharing now, right? Can everybody see?
Yep.
Yeah.
My desktop. All right. So basically, I am still working on this thing I call Hover Sim, and so this is a 4 mecanum wheel robot, and you can see it there. And the idea is that fewfold. I'll use this as a kind of a platform for. I want to make something that can simulate a hovercraft's motion because it can move in any direction, and then because it can translate front to back, side to side, and then also turn around. I've been using this to work on the kind of software framework that'll let me just control arbitrary motion in a couple dimensions, right, in a 2D. So basically, what I've been doing in the last, well, since last we met in person, was that I've added this display. And
Hey,
right
Carl.
now,
Real quick question. I don't know, maybe I'm not using this right. I see your face talking.
Oh.
I don't see you presenting anything.
Yeah, I don't see your desktop either.
Okay. I thought maybe that was just me, but if everyone's the same.
can't share my screen. So nobody's seen my screen.
No.
Nope.
Well, that's bad. It worked the other night.
It worked earlier in this call.
Yeah.
Yep.
Even earlier. An error occurred, so I wonder. Maybe if I just try a window.
I don't know if others got it, but there was a message saying you joined. Yeah, Carl joined. There you go. Okay.
Oh, you're there.
Now I can see a cool
Part of it.
phone.
Yeah.
Okay, so you can see it now, right?
Yeah. Got it.
Just the phone part for me.
Oh. Hopefully big enough. Yeah.
Yeah.
Yeah. Okay. So this is the 4-wheel robot, mecanum wheel. And what I've done here in the last couple weekends is I've added an RGB display so that I can. The whole idea is like we use a lot of encoders, Ray, Alan, so that we can know where we are on the floor. And there's a kind of question because the way these crazy wheels work, whether you could really rely on the encoders for them.
Oh, yeah.
So I've been setting this up so that I can run. We have a thing called Quick Trip, which basically means drive forward a big distance and then come back a big distance and wind up in the same spot. But it's a really nice little kind of a benchmark to see if you've got decent encoder control, and you can also calibrate too, right? Because you can just move a certain distance, count the ticks, and then calibrate per distance. So the whole idea is that now with this display, first of all, I can keep track of the velocity. It's showing the velocity in that kind of mode. And then the whole idea is that I can run a calibrate forward test. So this moves all the wheels forward for a little bit. And then when I finish wiring it up, it'll show the encoder delta before and after. So I'll know distance, I'll know ticks, and then I can calibrate. And I have it so that I can calibrate going sideways, so that I can calibrate going diagonal. And anyhow, so I've been working on getting that going and then making the RGB kind of useful. So like, let's say this is using one of these PS2 controller things, right?
Mm-hmm.
So let's say you lose the link. Ooh, that's bad, but I trapped it. So that's been something. Then I have to reboot it. But that's what I've been working on here. And once I get that settled down in again, then I'll get back to the other thing I've got, which is we have this kind of a club robot thing. The base, the club got together and built this kit from the ground on down. and then I went and added this upper deck in a Raspberry Pi. So right now I have it set up where the Raspberry Pi sends commands via the SPI port. So Raspberry Pi is a master, and there's an Arduino Mega buried down in there as a SPI slave. And I've got this set up so that I can get the communications protocol working. But then ultimately what will happen is that we'll take this camera and then I'll be able to run this in either configuration, either as a donkey car with the neural net mode, or then it's as a kind of line following project that I've been working on. We have a challenge course for line following, and been working on that. So well, that's what I had to share on the robot side.
That's really nice.
Yeah, thanks. And the oscilloscope traces were showing. I've been paying attention since I use the interrupt. I have a 50 hertz loop, so I was using that to keep track of how much overhead, how much spare time I have in the processing dimension. I do a lot. My debug mode is console logs, not very good, right? And then this display, and both of those with all the strings really chew up time.
Yeah.
But well, that's that. Okay, so with that in mind, would you guys like me to? I was going to just give a kind of show and tell on what I've learned with Visual Studio Code and Arduino and Git, some stuff like that.
Sure.
Yeah.
All right. So I know Steve, Mr. Microsoft, there, you're no stranger to VS Code, but is anyone else on the call using VS Code?
No.
No one else. Okay. Hey, before I get started, well, we have Doug and Ron Grant who joined. Hi guys, welcome. So we were just going to get started with. I was going to do that. We went through, and those of us so far have talked about the projects we're working on. So how about if I'll go through the little mini ad hoc presentation I have on Visual Studio Code, and then we can follow up with you guys if you want to talk about your projects, and then we can help Jack with his power issue. So can everyone see my screen now with VS Code? Or?
Can you hear me,
Yeah.
Carl?
We can hear you now, Ron.
Okay, great. Should I mute my microphone? Does that create a problem?
Either way, it doesn't matter.
Okay, I'll kind of keep shut up. I won't blurt too much. Pam's laughing.
No doubt. Hi, Pam.
I'm late. Sorry. We ran out of hand sanitizer, so the only thing we could get today was gin. So if you need to, cut me out of the call, that's fine.
Awesome. We'll see if you can last to the end. All right.
Okay.
Also see Doug, but he's on mute.
Oh,
so
yeah.
We can't hear you yet, Doug. If you
we don't know what he put in his coffee either. So
can I scroll my list of people that I can see people? Sorry, and I'll shut up pretty soon. I can see people. Can I scroll them? How many people are here?
8 people, including you.
Okay. Wow.
Yep. So okay. So can y'all? No, I haven't. Where is the window?
Okay. Can you see me, Carl?
Okay. Yep. Yeah. Hi, Doug. We got you. So I'll go through this Visual Studio Code stuff, and then we'll go around and catch up with you and Ron.
Okay, sounds good.
Sounds good.
All right. So everyone can see my screen, I presume. Can anybody not see my screen?
Looks good.
Looks good.
Right.
Yeah, there we go. Okay. Sorry, I'm sort of learning, so ignore me if I create a distraction. But
Okay. All righty. So basically, Microsoft has this free editor, and it's so good that it's used commercially. At least my guy in India uses it for our production code. But it's pretty robust, and for the price, you can't beat it. Visual Studio Code. It's on a handful of different operating systems, and it's got some really nice features, and it's fast. I'm running is it the February, the January one, but 1.42. If you decide to try this out with Arduino, I recommend that you downgrade to the 1.42 because the latest 1.43 has an issue with the Arduino plugin. The serial monitor doesn't work right, but in any case, what I thought I'd do on this ad hoc thing was not go through all the details of setting it up, but basically just show you some of the workflow things that you could accomplish. And then if you want to take on the learning curve, I can set up a more in-depth setup and get trained kind of thing. But for this little session, I thought I'd just run you through and show you what it can do.
What's this called again?
Jack, this is Visual Studio Code, Microsoft Visual Studio Code.
Oh, okay. Thank you.
So you said for the price, what was the price?
Free.
It's free.
It is free. Okay, yeah.
Your favorite price.
Yeah.
So like a lot of IDEs, right? You got the typical frame and such, and the menus on top. But if you walk down these icons on the left, you see at the very top you've got this kind of file view, and if you click it, it opens it. If you click it again, it closes it. So here I got in this, and this is a Git repo, set up as a Git repo, but I've got a folder with some documentation stuff, and I've got this is a really simple thing. This is what I use to get the SparkFun RGB display that I just showed you running. So you can open, just click on a file and it opens it, and like any old thing, it happens to be C aware, nicely C aware, so it highlights and things. Other things. So you can search like if you do Control-Shift-F, you can search and it'll find you all the different occurrences and all the files. So here in the configuration, I just searched for Arduino. It's got that reference in the. This is a configuration file for the Arduino plugin. It's got all those references. Here in the source code, it's got it listed a few times here. So it's kind of handy. And if you click on this thing, you can actually go down and do a replace if you wanted. So if I did, I'm not going to do this, but it would show you all the different instances where it would want to replace Arduino with 1500. So that's kind of handy because you can preview the search and replace, and you can accept or reject individual ones. And then like this shows, I'm going to bounce around a little bit. So like, let's say that I accidentally hit accept. We're going to do this. We'll just accept it down here in the code base. Where's the button? It's hiding on me. All right. Moved out too far. Yeah, great demo. So there. Okay, now I can accept, like I'll accept everything in this file and everything in this file. And, probably I don't want those, but like you'll notice that when I did that over here, this thing changed. So if I click on that, this is this Visual Studio Code is aware, it's Git aware. Kareem. Hey, Kareem. So it's because it's Git aware, Git keeps track of any changes that you make, okay? So here now it's saying that these two files have been changed. So I can click on this file and it opens split screen and says, oh yeah, well look at that here.
So Carl,
yep.
Just to be clear, that's assuming that you have run git init on that folder or you clone this already. It's not going to get aware on just any folder.
Oh yeah, right. It has to be a Git repo.
Yeah, or
Yeah.
you can just initialize the local database with Git, and it'll do it.
Yeah. Thank you, Steve.
Yeah.
But you can see how handy, you can imagine how handy that is now, right? Because it shows that in this file, it's changed from Arduino to 1500 in 2 different places, right? Or over in the LCD file, you can see it highlights on the right. The red is a subtraction and the green is an add. So vertically, as you step through your code changes, you can make some changes, and when you get comfortable with them, you can stage them for Git, and you can just kind of like, well, these are working, now I'll try some more things that I'm a little iffy on. So you can just keep working and working away, and then when you finally get comfortable with it, you can click this button, make a commit, and or like in this case, I really didn't want to do that, so I can unstage all these, and then I can say, yeah, let's just discard those changes. And it puts the files right back the way that they were. So no accidental changes to the code. So that shows you Git. It shows you files. It showed search. And then that also, Steve was hinting, not only did that, for that to work, this had to be set up as a Git repository, but also I've got some things in here, like there's a lot of extensions you can add. So I have a C++ extension installed, which is like language aware, and you can get these plugins for Python and JavaScript and whatever else. And I've installed Arduino, and I've also installed a couple different Git clients. So like this particular one lets you look at the history of the file in all of its different versions. So you can also see that I have like three different branches here, 1, 2, 3. So I can click on like this one, and then it shows that in this commit, based on comparing that to the prior commit, these 2 files changed. So I can go in and see, what changed. And in this one, I'm ready to just throw sprintf in the wood pile, bury it so it never returns again. But this was reminding me of why, so I can go back and rewrite something that works instead of sprintf. And it keeps track of, like, in the configuration file here, I used to use it on COM5, and then when I switched to a different board, it went in COM4. So it keeps track of a lot of stuff for you, and that's pretty handy.
Hey, Carl.
Yeah.
Could you? You said you had 3 branches. Can you show? Yeah, I'm a Git beginner, and I use it to do like version control, but I know that branches could be powerful, but I'm not sure exactly how. Once you're out there, you come back in without screwing stuff up. Can you kind of like look at your branches that you have on that repository and show me why you made a branch and then why did you come back?
Yeah, let me show you with a different repo actually. So let me open that other repo. All right, let me present it. My entire screen. Is it working now? Hey, it is working now. My whole screen. Good. All right. So basically, this project I'm going to show you is the project that's driving this robot right here. Is that showing is the robot showing as well?
Yeah.
Yes.
Presentation. Okay, good. So that'll come in handy in a minute. Is that working again? Yeah. So this repo. So this is the project that's driving. Let me simplify it a bit. And you can see, you can get carried away with split screens, and there's a it's a low bar to get started, but there's a lot of learning and a lot of growth you can do. Yeah, so all this code, so you can see if I open the file view here, close this, you can see that I have a handful of different files, some HCPP, and then the Arduino. Another thing, before I'll get to your, and I will come down to this later. So, yeah, so Doug, you were asking about using the Git for a project like this. So let's start by...
No, actually specifically about, well, yeah, I really wanted to understand the philosophy of using branches and how do you use the branches and how do you bring them back in, and because that's, I'm not really sure. Yeah, like why did you?
Let me show you. I'll walk you through how I did this. Okay.
Okay.
So, so basically, I started off this project. This robot started off with code that I got from the vendor of the driver board, and I started off with that, and I just started hacking on it. So, like if you go to this, so I started basically, Doug, with a kind of an origin and a master branch. That's the kind of baseline branch at the moment that this started with. And in here, you see that it added these two files. So it really just started with this one file, and this was it. It was all in one ugly file, the way that it came to me. And you can see that, or no, actually, this was the baseline I took from a different project. So however it was, yeah. Okay, so then from there, then I just started making changes, right? So at some point along the line, this is the one branch that was origin master, this kind of orange one on the left.
Right.
But then at some point, I decided to go do these things in the green branch, which is where I said I was going to refactor the original source code to classes, because it was all flat, it wasn't very nicely structured. So like this was the baseline code. So then the next branch, so in this one, I just focused on manipulating things related to the branches, right? So in this one,
well, okay, Carl, why did you create a branch? Why didn't you just like revisions?
Well, so the logic was that I knew that at some point I wanted to restructure just the framework of the code. So that's what I put in this. Then I knew that there would be times when I wanted to focus on encoders. So I put encoders in their own branch. There's times I wanted to focus on control loops. So those were separate. Times when I wanted to focus on the operator's PS2 controller, kind of related stuff.
Close the door, please.
Times when I wanted to focus on things related to the display and things related to calibrating the encoders. So basically, I split down, in my own mind, I split into these different kind of functional areas, bits of code that related to each other. And the reason for doing that is that now I can really, at a glance here, I can look at these and say, well, the last time I worked on the controllers was March 8th. And then from March 8th to March 10th, I worked on this. And then from March 10 to March 22, I worked on the LCD display. So it lets me keep track of, what I was working on at any given time. And then you can see now that I've been bouncing around back and forth, because here I took the one branch and then I worked on the LCD, then I jumped over and worked on the other thing. And, at some point then what you do is you can say, well, the LCD is stable. These bits and pieces, I made some progress on the controllers, but then I parked that because I wanted to have the displays so I could monitor what's going on. So I left the LCD in a kind of half-baked state, and the controller, and then I worked on the LCD, and I moved the LCD back into the main branch so it was, nice and stable. Then I pulled the LCD back into the PID so I could get visibility. And so you can use the branches to kind of separate what you're working on and keep your separation of interests clear, right? So you can pursue different branches at the same time. And then in the real world, Steve will correct me on this, I'm sure, but you might wind up having like one developer work on one area, another developer work on another area, so you might have 100 developers all working on the same code base, and all of their own functional area code is in their own little branch.
Yeah, it's usually in larger teams where you have different feature groups. You have a shared code base that everyone is working with, and when they start working on a feature, often their feature work's going to introduce a lot of instability into the code base. And so they'll branch it, and they'll start working on their own branch based off that main tree of code, the main trunk. And they'll work on that until such time that it's stable enough that they feel they can merge it back in. Now, at the same time, there's more than one feature team, so there may be other teams doing the same thing, working on their own features. And so they're not really dependent upon one another unless the features are somehow related. And usually those two teams would need to work together in that case. But if they're unrelated, but they both would affect the main code base, basically once the feature is ready to be, to pass all the tests, they've done all the demos, got all the approvals, then they usually can then merge it back into the main line. And then as the other feature teams are finishing up theirs, one of the processes is to do integration testing. And so then they pull in the latest tree into their code. They basically take the master tree and they pull it into their branch to make sure that their code still works with the latest code in the master branch. And once that's all tested again and their feature is now working and works with the latest branch, then they can merge it back into the master branch themselves. And that's
okay. So Steve, if you look at Carl's Git repository up there, before the second master dot from the top, you can see that he goes from a master to a branch. Is that what you're telling? They bring the latest code branch in? Is that an example of that?
Yeah.
Okay. So then he would bring it into his, okay, I'm seeing how it works now.
Yeah, he pulls the master into his branch, then he tests to make sure that his new code works with the main branch, and then whatever fixes he did there on, they added several more things, then he merged everything in.
Okay.
Back into the main one.
Yeah, when it's just one developer, you can really use these branches however you want. A lot of times it's just you want to test something before you commit to that in your main branch. You don't want to start creating a whole new version. Maybe there's a contest coming around the corner, but you have a good idea for a new routine. You can create a branch, go start working on that new routine, and even if you don't get it done in time to use it, you can just switch back to the main branch, knowing that code still works, without that new routine.
Yeah.
So it's a way to separate that kind of work.
It's pretty awesome in that way because you can say I have a bunch of branches here, right? And except that I'm working on this at the moment, so I don't want to do it with this repo. I've got these staged, but I could very easily go and select any one of these branches, and in the blink of an eye, my code, the file system would take care of changing the file system underneath, and you don't have to worry about. So however many files are involved, it just puts the current latest batch for that branch, and that's what's in the editor. Bam, it's done.
Well, okay, so if I look again over here, if you look again at that second dot down from the top on the master, now go on the master to the top, now go down one node.
Yeah.
Okay. So at this time, go down another node.
All right.
Okay, so at that one, the other guy's branch isn't brought in. So he's essentially using where he branched off from wherever, right? Otherwise, he's at the third node there. he's not, he doesn't have, to me, it looks like a pink, but I don't know if it's pink. Yeah,
it's purple, but that's close. Yeah.
No, the purple I can see, but the next, yeah, that guy, he's not in there yet. He hasn't merged with the master. So the master at that third node, which is where the purple came in,
right,
is using whatever code that guy had way back in the beginning.
That commit right there.
That's right.
Okay.
So
Okay.
this commit is the same as this commit. And then these changes here, 1, 2, 3, these changes were all built on top of that point.
Okay. Okay.
But well, this is a good thing. So watch what you can do here, Doug. I can say, take this one, select it for comparison. All right. And then let's come back over to here and say, I hope it works this way. I think it does. Compare with. And then I come down here, and this shows me what's different between those two branches. So between this commit hash and this commit hash, I can see that I uncommented this debug serial print line. I added a serial print line. So, and that's what changed in that file. And it'll show you what changed in this file. Oh, that was quite a
couple things.
Quite a couple of, it was a busy day. So, but you can see though that even for a single person, it makes things so visible and so traceable, because now I can tell, here I got 4 different files that changed between those 2 different points in the history. And it very clearly shows me when did I do it, with respect to what other changes did I do it. And it's just a really powerful tool once you get over the first few humps. But that,
okay, all right.
We're at the difference between these two right here.
Yep, I got it.
Hey Steve, would this work? Do you have to use or develop code, I guess, in the editor for this, or can you bring in code, say, from STM32Cube IDE or something? Could you do that?
This has no requirement on any tooling or anything. So
okay.
if you basically download the Git client and do a git.init on that folder, it'll create the database. Then anything you put under that folder is tracked in Git. And so then if you open it in Visual Studio Code, then you get all this just for free, right? Because we're just integrated with the Git client. So if you do your editing in this, then you get all the features that he's showing you here. But you can just as well edit this in the STM Cube thing, the IDE. Yeah. And then if you need to load this up and see, oh, I need to go commit stuff or change stuff. I don't know if the STM has any IDE integration with the Git client. Maybe it does.
I think it does, Steve, but I'm not absolutely sure. But since it was Atollic, I'm kind of pretty sure.
There you go. In fact, debuggers.
Yeah. You can basically this got a lot of add-ins too for that kind of stuff. But essentially you can use whatever editor you want, and when you save it, and then you look at it through the Git client, it knows, it can compare what commits have happened, and then if there's any changes, what's changed. So you can still do all this stuff with this, even if you use a different ID to edit the code, as long as it's in a tracked folder.
Hey, Carl, can I ask a quick question? Can you search for Cube and see if Emmet or whatever it is called, STM Cube, I think?
STM32Cube IDE, maybe?
Yeah, whatever. Yeah, Cube MX. Is it by any chance? Have they got it knocked into this?
No.
No. Okay. All right.
Well, there's a bunch of STM32. Yeah, there you go. set up STM32 projects generated from STM-CubeMX. So yeah, you just have to search. There's a ton of stuff out there, and that's what I was just at a high level. I was going to show you. These are the ones I have installed. Arduino C, a couple different Git things, Markdown, Lint, Python. I'll show this at different times. The remote editing is really cool. SVG viewer, XML tools. I mean, there's like a PDF viewer. So here's a code editor, and I can open I can open my super high quality schematics, right? So that's the adapter board for my LCD display.
Okay, hey Carl, could you do can I ask you to do something? Can you write down? I know you've got probably a lot of extensions into this, but just the extensions that you would say are key for somebody who was working on Arduino. Let's just keep it simple. All of the extensions, the Git extensions, the Arduino. There's probably some AVR debug extensions. I don't know what else is in there, but whatever it is, just if you can just send that out in an email, that would be cool.
Yeah, I'll be glad to do that. And we're running out of the hour here. You guys good to keep going a little longer?
Oh yeah.
Sure. Okay.
Yeah. Because we need to, are you going to cover any debug extensions that you got? Do you have? I don't have
any debug. I mean, the thing is that this whole thing is so rich that I was I was just going to highlight and show you that it exists, and then we can decide how to drill in later. And there's a couple more things I wanted to show you before we run out of time. So, for example, the Arduino plugin. So I've shown you just the value of Visual Studio Code and Git, and the fact that it has extensions, and you've gotten a sense for some of the things you can do, how powerful it can be. But then I was going to show you just normally, many of us or most of us use the age-old Arduino IDE, right?
Well, no, I use Atmel Studio.
Okay.
Or what it's called now.
You've got the advanced Atmel Studio. So I've gone just straight to Visual Studio Code, and I'm so happy for it.
Yeah.
I haven't yet gotten to the debuggers. As it turns out, there's a way where with this this Arduino plugin, there's a way that you can set up a JTAG emulator and set debug points here in Visual Studio Code and step through your Arduino code using the JTAG debugger. Apparently, there's a way to do that.
Yeah, but I don't know if it's going to be a JTAG. I would have thought they would have to have you'd have to have a JTAG adapter, because I think only SPI.
Yes.
Yes. Wire or whatever they want to call it.
But I'm saying that from what I read, that's available with this plugin in this environment. Okay. But for now, just to get started, you'll see that I got down here on the lower right, COM4, and I've got this serial port monitor. So what we can do here is I'll do this one, and let me clean this up just a little bit, and get rid of this, and drag my other screen over. My family is really in family communication mode, so pardon the messages that show up. Unbelievable. Okay. So, yeah, so what you can do in here is, I have it set up so if I do Control-Alt-U, it'll compile. There, so you can see it's compiling. Wow, it's really slow. There it goes. Yeah, and you can see here in the bottom, it says it's uploading, but I guess it's still compiling. I haven't tried this with the screen share like this, so I think I must be slowing down my poor PC.
It looks like you have verbose on.
Yeah, but it normally flies. I'm not used to doing the screen share and my iPhone streaming, and it's a relatively big project, I guess. But the point is that, you know, I didn't have to go to the Arduino IDE. You can do this all from within here.
Yeah, because I would like to have the IDE that ruled them all. Because I'm keeping my laptop up to date with the latest, whatever they call the STMs, and if you have TI's compiler, and if you have Arduino AVR compilers, you know, your whole screen's got about like 10 IDEs, all of them, 95% the same. It'd be nice to have one that's just did it all.
Yep. This is that one for me at the moment.
Yeah, this one's pretty close for me too. I mean, as far as embedded stuff goes, because I can also use that platform IO for all the other boards, and this also supports Arduino now, so pretty nice.
And then
Carl, Steve, I knew you paid some money to buy an extension for Microsoft
for Visual Studio.
Yeah. So did that work out well for you, or?
For the couple of years I used that, that worked pretty well. But then it's, later on, I mean, there's a lot of boards that didn't support. So when we started moving to different ARM boards, so.
I got you.
So here you can see that then all you have to do is go down here and click the connect button, and it resets the Arduino and starts up the console log. Put the auto scroll back on so you can watch it happen. Yeah, so it resets, and there it goes, flies along. And then I can turn on the controller. You can see the when I turn it on, it registers, at which point then I can push the buttons. And you can see the values change over here as well in the console logs. So yeah, from a one-stop shop, it's pretty handy kind of a thing. I've been really pleased with it. So let me see. So I think based on the list I had, that was primarily what I was intending to cover. On this.
Is it my turn yet?
Huh? Yeah. So let me stop presenting, and we can move along. So and then if this works, we can talk about it if we want to do this again next week or what. So,
let's do.
So we have Ron and Kareem and Doug had joined in the middle of things. So Doug, you're visible. Do you want to talk about the project you've been working on here?
Yeah, give me a second. Let me show you this. Okay, you guys all know what the standard little robot that I've been screwing with for this class looks like. Well, this is the, let me get it up here. This is the version for the Sumo. So now it's this one's still working. I'm still adjusting some holes and stuff. So I've taken this thing apart about 60 times. So that's why it doesn't have. But this is a mount for a sonar. And it's got side sensors. It's got back sensors. I don't know if you can see it. It's got sensors in the front. Are you seeing any of this?
Oh yeah.
Okay.
Are you going to have a scoop on it?
Huh?
So you're going to put a scoop of any kind on it?
Well, this sits.
Oh, it sits like that. I see.
Okay, at a 17-degree angle. So it's got down, like I say, it's got down vertical drop sensors. on the front and back. It's got sensors on all sides, so you can detect your opponent on the sides. Yeah, not very far, but it's more of a concept. You know, I'm not claiming this is a great sumo robot, but what it would do if somebody used this as a training platform, they would learn a lot about sumo. You know what I mean? So anyway,
Cool.
that's so I'm really pumped on that. I'm hoping that we'll sometime get out of this virus problem and where we can actually have the class. Okay, that's it.
Cool. Nice.
Thank you.
So Ron, you've got dancing dolls. What are you working on?
Oh, wait a minute. Let's see. Can you hear me?
And we can see your setup there.
Oh, okay. Yeah, well, not much is going on here. I've been kind of working on a number of different things. Let's see if we can see. I'll just for fun for the future. Oh, I need to get my camera worked out. I've been working on weird 3D printed stuff, little compliant, I don't know what you call them, buttons and things. Just got a desktop mill, but I don't know how to use it yet. I had these ideas. I was going to do some circuit board stuff.
Other mill? Oh no, I guess a carbide.
Yeah, my brother sent it to me because it was taking up space in his shop. He's a little better off than I am in the world of stuff. But I figured I'd start with a real simple circuit. You can see I really like to push things to their max. Anyway, so I started with that, and all I've done so far is I've done some acrylic etching because that's sort of what I do. So anyway, so there's an 805 resistor, and it looks like this mill can handle the etching. But now what I need to do is get the hang of doing copper etching. I thought that's kind of neat. I know like Dave Ackley and people like that have taken, like $100 desktop mills and done some pretty amazing things. But I'm just getting started with that. You know how it is, all these tools, 3D printers and all that stuff. It's hard to keep up with all of it. But oh yeah, so just for fun, I need to be working on my robot, but I decided I should animate one of Pam's dolls. The rubber band broke off on the head of this doll. So, naturally what I've got to do is I'm shooting for at least 3 degrees of freedom. And I don't know if I can show you, but what I've got, I don't have her hooked up yet, but I have a head tilt. And anyway, so down in the base of the doll, I have rotation servo. You can see it's active, and then I have a head tilt servo, and I need to get that hooked up. And then I'll actually have a body pivoting servo. So I kind of wanted a creepy doll. It bothered me that she was gonna, sell this on eBay for like $5 with a broken head. And I said, oh, I can animate that. So that's something. But I've got a lot of little piddly projects that are sucking my time. So right now I'm pretty worthless as far as robots go. Although I have dug up a project that Will did for me some years ago, and it's a tilt and pan eye mechanism, and it's really pretty clever. And I thought it would be good for me to get this back up and running. Had a servo fail in it, and in fact, right now, what I was doing while Carl was talking is I was building a 3D model of this. Will had built a AutoCAD. Multi-view drawing, but I seem to like whatever 3D models. So here I am, whatever in SolidWorks. Let's see if I can bring up his drawing, which is very nice. Hang on, let's see, where is that? It should be here.
Hey Ron, how is Will doing?
Good. Yeah, he's keeping himself isolated, which is a good idea, I think. Mm-hmm. So yeah, here's the drawing he made. Let's see if we can get this. Hang on, let's zoom out. Yeah, so he built this, and he works in, top, front, right side, multi-view drawings. And as he points out, really, this is the way we can build stuff is in 2 dimensions. It's kind of hard, although you can build things in 3 dimensions, but really a lot of engineering happens in 2D. So that's how he built this this eye model, and it's pretty clever. Let me see if I can zoom in. Really neat in that. Let's see if I get my finger in here. Let's see, and I not have it shake around too much. You know what? Let me see if I can mount the camera on the desk so I'm not shaking it. Let's see. Oops. Let's see what I got a light. Hang on. Where is that light coming from? Hang on. Let me kill that. Okay, hopefully it's not too funky of a view of the screen. I guess I need to learn how to cast my screens, which this computer is actually not hooked up to the internet right now. Wait a minute, let's see if I can get a decent image that doesn't make us sick. Oh, gee, it's not looking too swift. Hang on. Hang on, let's see. This is a...
that computer won't catch a virus. It's air gapped, so that's good.
Yeah, that's right. Yeah, that's, hang on, give me a sec here. Let's see if I can get this. Oh, what the hell, I'll hold it. Anyway, he's got this real cute mechanism wherein the eye, and I'll show you in real life, is constrained in this faceplate. And it's really neat in that when the servo rotates, he has a linkage, but he's got this situated such that the eyeball mimics the servo via the linkage, such that the eyeball pivots about its central axis. I mean, another way to do this, if you don't have a flat face, which is what he was going for, is you could actually allow the servo to protrude and directly connect the servo to the eyeball for the we'll call it the horizontal gaze. But in this case, he devised a linkage such that the eye is constrained in the faceplate, and yet it rotates beautifully without any connection to the faceplate. Just the fact that it's nested in the socket. Let me show you what I'm talking about. So here you can, let's see if we get ourselves down. Let's see. So there is one eye, and sorry I don't have this connected to a computer, and I don't want to force the servo. But here you can see his linkage, and literally that eye, oh gosh, this is pretty pathetic. I'll work on perfecting this. But anyway, as this servo rotates, the eye rotates about its central axis. In fact, here is one linkage with just the, let's see if we can get this. Hang on. Anybody throwing up yet? Let's see. So here you can see his linkage. Hang on, getting there. Oh, overboosted. There we go. So there, it's a parallel bar linkage. And anyway, that eye, when it's constrained by the eye socket, or by just actually a circle around the major diameter of the sphere of the eye, as the servo rotates, the eye rotates about that axis. It's really cool. I'll bring it to the next meeting, or I'll have a demo. How's that? Okay, enough of that. But yeah, as you can see, my desk is littered with various circuit boards and garbage that I'm working on right now. So really, this COVID thing hasn't affected me at all, except we didn't hoard toilet paper. So I guess we're going to have to figure out some way to deal without toilet paper. I was more worried, whoops, you'll get me in the picture, I guess. I was more worried about protein, fat, and carbohydrate and micronutrients, and I kind of forgot that maybe we need paper products. But anyway, I think somehow we'll figure that out.
Old newspapers, Ron?
What's that?
Old newspapers are good.
Yeah, there you go. Or we've got a 30,000-gallon swimming pool. Just jump in there, hey, right?
Oh, yeah.
I mean, the ducks are there, so what the hell? Chlorine takes care of it. Now that it's getting warm.
Almost warm enough.
There we go. Oh, there. Now we can see my dome. Okay, I think that's about all I've got to say. So this is interesting. I'll try to work out maybe better camera schemes, and maybe Carl. Oh yeah, you got to see Pumpkin Man too. Check this out. My neighbor. Can you believe it that they tossed Pumpkin Man? So now he sits on my laser cooling tank.
What a crime!
Yeah, he's pretty awesome. But again, the lighting looks pretty poor in here. I'll have to get that worked out. So.
So is that a distillation column you got in there? What is that?
Oh, what's that? Oh no, that's my laser. Yeah, so I went with a real simple design. I guess back in early 2000s. In fact, my very first balancing robot controller, I ported over to a laser. My brother at the time, back when CO2 lasers were kind of a new special item and not like common $100 goods now. But anyway, so that laser is mounted vertically. And I had a pair of XY tables that, back 20 years ago when I was doing contract work for TI, they handed me a couple of XY tables, beautiful tables. But then a friend of Will's, a friend of mine, managed to give me a slightly out of spec, and let's see, what do they call it? Shoot. Okay, I can't remember the name, but anyway, they're really nice XY tables. So I have my laser mounted vertically. And I'll tell you, it's pretty slick. There's no, the optical path is very simple. So we just have a beam through a single lens. And the mass of the tables makes it a little tough to do like raster scan laser stuff. But I can do a pretty nice job of whatever laser CNC stuff. I can etch and cut. And I guess I wrote all the software for that. I wrote a DXF translator, I don't know, many years ago to take DXF and also Bezier curves from Adobe Illustrator files like Corel Draw, I guess now GIMP. So I can take cubic curves and generate, nice contours with the laser. But now I'm sure a $300 laser from China, you can do all that stuff. So anyway. But that's yeah. So I'm kind of happy. I have a nice little shop that, nothing is production stuff, but I can do at least, 3D printing and stuff like that, maybe even circuit board production. But I tell you, I like Osh Park and stuff like that for making circuit boards. I have always a constant flow of simple boards that I use them all the time. So.
Well, have you made a board here just recently? I'm just curious if during this crisis.
Oh,
are they still?
Yeah, as far as I know, the last board. Let me look around. Last board I had delivered was probably about 3 days ago. Okay. So I don't see any evidence of them slowing down. I'm sure for many people they're considered essential. For me they are, but. Right now, a lot of my clients are in hibernation. So unfortunately, I'm not connected to people that have to stay up and running so much when there's, things shut down. So that's all I got. Anyway, but this is fun. I'll try to improve the video stuff. And I guess somebody can tell me how to. So right now, am I able to capture a screen sort of thing with my setup?
Well,
or how
you've been recorded the whole time,
okay.
But on Windows 10 you can do, I think it's Shift Windows S, and do a screen capture of an area.
Oh, but I mean, how do I? Is there a way I can screencast live, or how does that work? Like you were, Carl.
So there's in your Google Hangout window on the lower right corner. You can you should be able to find a thing that says present.
Oh, okay. Oh, I see. So if I show you my screen, select a window or screen. Okay.
Yeah.
I can pick any screen sort of thing. Got it. Oh, I see. Okay. So right now, can you see my main screen or whatever it is? Let's see. Hang on. Let's see. Hang on. 1 second. Let's see. Can you see like that drawing? No.
Not yet.
Okay, wait a minute. Oh, let me look at the menu, and I won't suck too much time. Wait a minute. I have screen 1, screen 2, screen 3.
So we can practice offline too, Ron, if you like.
Oh, okay. You can. Okay, great. Okay, then get rid of me. Cancel me. Whatever. Go to the next person.
All right. I was going to say, Kareem, you've been patiently quiet there for a while. I wanted to introduce you to Alan, since Alan is actually in Colorado and involved with school robotics teams. And Alan Kareem is one of the coaches for the team I mentioned here in Dallas. So Kareem, what have you guys been doing since they canceled the season and then increasingly sort of locking us indoors?
So yeah, we've been. It's been interesting. We did advance to Worlds, and they have now canceled Worlds.
Oh boy!
So that's a bit of a bummer. We got they canceled the entire season. So whether you're FTC or FRC, or I guess those were the only two that were still going on. So everybody's casting about trying to figure out what to do. I've also shut down. So we do our practices at our house, and I have I've shut all that down, and we're trying to do virtual meetings just like this. So we had our first last Saturday. Otherwise, we would have been full steam ahead. The season got canceled 2 days before Texas State.
Yeah.
So we were about to go to Texas State, which is just here in Dallas this year, and got canceled. And then last week would have been spring break, and we always have a big push during spring break if we're going to Worlds, and so we would have done a lot of work then, and so everything's just settled down and sort of gone quiet. Is my screen, is my camera presenting by any chance?
No.
Yeah, I have some issues with that. I'm not sure what's going on. Otherwise, I'd sort of show you the state.
Can you unplug it and plug it back in?
Huh?
Can you unplug?
No, it's built in. It's built into the laptop.
Oh, I see. Okay.
And it even says, it's got the recording light on at the moment, but
weird. We're seeing
I had a couple people tell me that it's just not working.
Yeah.
So I got probably a driver issue or something. Otherwise, I'd show you. We were at the state where we were close to completing our second robot. So when we try to go to Worlds, we try to build a second copy of the robot. You're only allowed to take one per competition, but it's sort of the refined version where all of the mistakes hopefully get worked out. And the goal was for the first time, this time to have it in far enough in advance where we could have drivers practicing on one of the robots, and we could have coders working on updating the autonomous routines on the other one, and switch back and forth. And we were actually going to be there where we could do that this year, but we're still hoping to do. They're talking about doing a virtual showcase, and we're not sure who's going to be invited to that, but we're hoping to complete our second robot, continue working on the code base, and get a nice killer, what they call a reveal video.
Nice.
Working. But the problem is for FTC in particular, the one that I like, and my team is part of, is the kids are supposed to do the work, and they're not able to come over right now. So we're trying to work out a way where I'll just sort of be their hands during a virtual meet, and they got to just tell me step by step what to do, so that we can complete that second robot. They can do more of the coding stuff remotely, and we can use things like this. We use Microsoft Teams, and we use GoToMeeting and Google Hangouts. It all depends on who's leading the particular meeting, and we'll bounce around between those things. But we're trying to work it out. We're trying to keep the kids active. They're all in Dallas ISD, and Dallas ISD is also shut down right now. So in fact, I guess yesterday was technically their first day where they were back from spring break, and they're supposed to be attending online classes, and so everybody's trying to use Google Classroom, but the teachers haven't really figured it out yet, so it's pretty haphazard, and there's no real solid understanding of how we're going to get to the end of the school year. But right now, everybody's projecting that Dallas ISD is going to be closed for the duration, for the rest of the semester.
Wow.
Yeah.
Hey, Kareem, do you have any seniors on your team that are missing out from next?
Yeah, I have one.
Okay.
This year we were really this was supposed to be a rebuild year, but we had moved so far along that I was feeling good that we were like a candidate for some of the highest end awards at Worlds, and so this would have been we think this would have been a really nice season, and luckily, I guess only a single senior is graduating this year, so most of them will get another crack at it next year.
Cool.
All right. Well, thanks. Yeah.
Sure.
Let's kibitz on Jack's problem.
I think that'd be great, but it looks like Jack has left the building with Elvis.
Oh, no. I'm here. The internet shut down at our place for some reason, so I've got to do it on the phone as well.
Oh, I think it'd be better with a screen share. Do you have a
I
way
can't seem to pull it up on the app.
Oh, screen share. Would he choose to be presenter?
Well, he's on a phone call right now.
Oh, he is. Oh, yeah.
Yeah.
Oh, there we go.
There you go.
All right.
You got your video.
So, Jack, are you still on a phone? It looks like it.
Oh, whoops.
Doesn't that Tesla have a conference room built in?
Not yet. How do we unmute this on the app? Is it Oh, there we go. Hold on.
We have faith in you being able to figure it out.
All right.
Complete faith. There we go. Welcome back.
All right. Is this working?
You're on, Jack. Yes.
Yeah.
All right.
So what are the Jack, what are the pieces then you're trying to hook up? If you give us a just summary there, what are the pieces you're trying to hook up and which ones are turning up?
Oh, sure. So right now it's this Mega, and I was originally plugging it into the motor controller shield, and when I plugged the Pixie in, it burned out my last one.
Okay.
Mm-hmm.
Oh, okay. So the Pixie was plugged into the Mega, right?
Yeah.
Okay. So that was using SPI port.
Yeah.
Okay. That shouldn't have screwed up your. Usually, do you know what's going on? I mean, is it another power supply problem? Or are you when you take your voltmeter and you go to the what is it? Is it V out? Is it called V out? I can't remember on a Mega.
Okay.
Yeah, and is it 5 volts?
I can double check. Hold
on. On mine,
I'll just bring this downstairs.
It took a little while to fail, but that's what I did, is just look at the output voltage, and if it's not 5 volts, that's most likely it. What battery voltage are you inputting into the board?
It's 4 cells, so I think that's 12 volts, right?
Yeah.
Okay, what connector are you using? Are you going in through the barrel jack with 12 volts?
It's
or are you using
one of these things?
The VN?
What?
Are you using? Okay, here's one of the problems you can run in on these guys.
Okay.
Is if you have 5 volts being supplied by the regulator, or by the USB board.
Okay.
If there's a little bit of difference in voltage, you really don't want to supply your Arduino with 2 sources of power.
Okay.
Okay. And if my thing, never use the VN pin. Okay, that's what I've found. If you use the VN pin, later you're going to screw up, and that's going to blow the regulator.
Oh, really? So don't use the VN pin.
Now that's what I would recommend, just from a safety point of view.
Okay. So just use the female port or something?
Well, if you're using a battery, if you can, use the barrel jack, because that definitely goes through the regulator.
Oh, okay. All right.
Okay.
It's probably been where most of my problems are then.
Yeah. Okay. Did that article I sent you help you in any way?
I haven't looked at the article yet.
Okay. All
Yeah.
right. Take a look. It's really a good one.
Okay. Yeah. Thank you.
It's the for the rest of the guys. I sent him a link to the article, which is you can get on the web. Is 10 ways to kill an Arduino board. So yeah, it's actually a pretty good article.
Yeah.
Okay. But do you think it's the regulator? I can get you, well, probably in this situation, what you might want to do to save your boards is just go ahead and order off of eBay or Amazon some, I think it's LM1117 5 volts.
Okay.
Regulators. Yeah, it should match, the picture should match the one that you have that's sitting next to your barrel jack.
Okay.
And then you got a soldering iron, right, Jack?
Well, wait,
Yeah,
what do you mean? It would, wait, does it go on the Arduino or something? Or is it,
on the Arduino board.
Oh.
There's a,
okay. Is it
package
that, thing that you soldered onto my last one?
Yeah.
Oh, yeah, I remember.
Just go order yourself 10 of those.
Okay.
And that way, because your chances of actually killing the AVR chip is really pretty minimal unless you do something really dumb.
Oh, really?
Yeah.
Okay.
Usually it's the regulator that fails.
Okay.
All right. So you can snap another one on there and recover your board. Because I don't know. Yeah, especially if you got multiple ones being failed.
All right.
Give that a shot.
Yeah.
Yeah. And you can read. You can read on the board what the regulator. But I believe it's an LM1117-5.
Okay.
Yeah, the Arduino website.
Hey, one other comment. The linear regulator, the current is going to be affected by the voltage drop. So if you're going from 12 down to 5, that's a 7-volt drop across that regulator. If you put an external switching regulator before, between the battery and your Arduino and drop it down to 8 or so, you're going to be burning a lot less power on the onboard linear regulator. Just another idea of blowing it.
Clay's right. To get the most current out of that regulator, you have to use about 9 volts.
Okay.
Yeah, because anything more than 9 volts is just turning into heat.
Oh, okay. Yeah. All right.
Do you have access to the regulator? Can you touch it with your finger? Is it red hot? Or?
Yeah. Hold on.
Just use your safe cracking finger so that if you lose your fingerprint, it's the right one.
I'm pretty sure he dropped off the call.
Oh yeah.
Yeah. The other thing too on that, usually it might not be hot because it's blown open.
Oh, it's fried. Yeah, that's true. Yeah. Mine got hot once and then never again.
Well, I got, I know I've blown 2 or 3 of them over time.
Yeah.
I know, like on 3D printers, like if you have a, what's the name of that board? The one that has the 3 drivers on it.
Oh, the ramps board.
Yeah, the ramp board. It comes with a diode to prevent you from screwing up a double feed. Because they use VN too. But anyway, that's something to think about. I just wanted Jack to it sounded like he was losing them by the handful.
Oh boy, yeah.
Yeah.
Well, he's probably plugging it back in the same way, I would guess.
Yeah. Yeah.
Yeah, it's too bad because that kind of thing is a little easier in person to deal with, but to help.
Yep.
Well, I think we've gone around the table and talked through everything. So I guess I hope everyone thought this was a pretty decent way to have a club meeting in these circumstances.
Yes, it worked out better than I thought.
Okay, cool. Well, I'll gather up and share the stuff I've found on Arduino, and I'll put an email out in a few days or whatever as I can get to it with the favorite extensions and the version number for code. But should we do this again next Tuesday or a week from Tuesday or Saturday, or what's the thought?
Well, you want to keep doing it Tuesday?
Let's try it every Tuesday until we decide that doesn't make sense. Okay.
Yeah.
Okay.
So it's safe to meet again, maybe.
Yeah, it seems likely we'll be in this mode for a while, but
yeah.
So, Carl, one of the things is ask for volunteers for next presentation. And
yeah,
let them know by Sunday. If nobody says, we won't have a presentation. Right?
Well, does anyone on the call want to step up and present something?
This is Clay. I can give a short presentation on what I have.
Excellent. Right.
Okay.
I still want Ray to tell us about his, well, I don't know. Do you have a Husky lens, Ray?
I don't have the Husky lens. I have the, it's the SciPede
OpenMV.
Max Pi, MAIXPY. It looks very similar to the Husky lens. I think you have I think you got like a 5 megapixel camera on yours. Mine's just a 2.
I didn't get I got the small, lower resolution, but mine's somewhere on a boat, from what I've been told.
Oh, really?
So, yeah. So we'll see.
What was that? Princess Queen or whatever it was from Japan.
Yeah, who knows? I haven't. Let me put it this way: I haven't got my Husky lens yet.
Not yet. Yeah.
Not yet.
Yeah, I've done some things on it. I was kind of surprised. The SciPede stuff has an IDE that's similar to what the OpenMV H7 uses. You know, if you look at it, it's like some of the icons change, but between the two. But you can take all of the examples from the OpenMV H7, and with a few minor changes, you can run them on that part because it's all Python. So between the Max Pi and the OpenMV H7, you can try out different things, and I forget what the guy's name is that does the OpenMV stuff. God, what starts like, I think it's W or something. Oh, Quavino, I think his name is. First name. He has probably 100 different examples of different things, from you name it, blob detection to linear regression to try to find, using linear regression to try to find lines and things like that.
Mm-hmm.
I asked Doug Ames if the Husky lens came with that, and he said he didn't see anything that said you could use that on the Husky lens.
Yeah, Husky. My understanding is the Husky lens.
Connected to your modem. Unplug it.
I've heard that the Husky lens documentation is still in progress, basically.
Yeah, I think it's very, it's not so great for the, the SciPede Max Pi stuff. If you can read Chinese, you're great, but if you can't, it's and even the English is very rough translated. It's, you know, you can read a paragraph and wonder what the heck they were saying. You know, it's like, I have not a clue to what you were trying to get across here, but you know, kind of like word salad, you know.
Yeah.
But, anyway, yeah, it's they're the Kendrite, you know, the K210. It's you know, very powerful, and it's got you know, an accelerator built in for convolutional neural networks. So you know, you could even use it as a replacement for you know, the OpenMV H7 or Raspberry Pi and the Pi camera. You know, I would say it's as fast as either of those.
Okay.
So,
Even the 4?
I haven't played with the 4 yet, but at least the 3B Plus. You know, you can do similar things, and it's I think the Max Pi thing was, I want to say 39, including shipping. I think that's what it was. So you can't really get a Pi 4 and a camera for that. So
That's true.
yeah. So, and it has, you know, it's got UARTs, SPI. There's a bunch of general purpose pins. Pretty certain it's got I2C, so you can pick the interface that you want to use on it to, you know, extract, you know, or whatever information you try to get. You know, you wouldn't use one of those to transmit an image across, because you can do processing on the board, and then, you know, like for the line following stuff, I was just sending an X coordinate for steering. That was using, you know, the OpenMV H7. But so it's, you know, hopefully the documentation is going to improve, and they've got kind of they have a forum set up, so, you know, hopefully people will start to contribute to that as well. You know, just examples and stuff like that. So.
All right.
So did Jack come back? Yeah, it looks like Jack came back.
So Jack, are you here? Was there more on that discussion when we lost you?
Oh, yeah. It doesn't seem to be getting too hot right now.
Yeah. Are you able to measure the voltage, like with a voltmeter or something?
Just about to do that.
Okay. Yeah.
Yeah. Hey, there's gonna be a competition in April, right? I mean, it hasn't been canceled yet.
Well, okay, so I'm willing to I'm willing to go out on a limb, and we've had a little discussion, a few of us at least, that it probably makes sense to try and cancel and reschedule.
Oh, okay.
I'll just go out on a limb and say that no matter what Lieutenant Patrick says about grandparents should just stand up and die so that we can go out and have an economy. Let's hope that that's not going to be the prevailing attitude, right? So,
did he actually say that?
Yeah,
pretty close to it. I was just reading the quotes. It was something to the effect of, I think grandparents would be willing to take a chance.
Yike.
Well, let's
Not very Christian.
not get too political, but I would. So, Carl, what's your thoughts? You think April 20? We said earlier we're going to wait 2 weeks in advance of April 25th, and then if it's still bad, we're going to just cut it off, right?
Yeah.
Yeah, that's what we talked about.
So that decision point's not really here yet, right?
I guess we haven't made the decision, so.
Yeah.
Yeah. You know, it's hard to say how this is going to go. So.
Yeah. So we don't have to make a decision till April 11th. So I guess well, yeah. Who knows? They might not let you into the makerspace.
Makerspace could still be closed.
Yeah.
Well,
So
I mean,
anyhow, we should be taking this time to work on the robots and get them ready. And if we can do it, we'll do it.
Is the challenge course still down at the space?
Nope. Ray has it.
Ray has it? Okay.
Ray has it.
No problem. I just, I was thinking that, never mind.
Would you? Could we meet do a dead drop somewhere?
No, I was thinking more that might be something that other people might want, but I was just wondering if there would be some way to virtually do that. Otherwise, if you could show a camera and see the run, because I know that's something that a lot of people have worked on, but we can wait. We can do it in January at this party at Steve's house.
Yeah, or June.
Yeah.
I mean, we could do it. Ray could do a video from his place. I have my practice version of it. I could do it, and I could playlist pretty close. We could probably do a sanitary trade if you wanted to borrow mine. So we could still do virtual. At the very least, we could do something like this and do a virtual competition in April. Maybe that's the way.
Oh well.
We just have to look for skips in the video. Like you're over moving along, and all there's a jump, and it's repositioned a little further down on the course.
Start working on deep fakes right now.
Deep fakes take.
It's getting garbled. Sorry, I can't hear you.
Oh, sorry. I said I'll start working on my deep fakes now.
Oh yeah.
I don't know if Alan's trying to talk. I hear a bit of stuff.
Speaker problems, I think.
Oh, okay.
Or connection issues.
Yeah.
Yeah, did my microphone come back? Can you hear me?
Yeah.
Got you.
Okay, great. I was screaming when the regulator problem was going on because I had things to say, not that they were of any value, but anyway. But my microphone was working.
Your mic censored you, huh?
Yeah, I think so.
Alrighty.
All right. So next Tuesday, same bat time, same bat place.
I'll send an invite out, and anyone that has ideas on presentations, please send them to me.
Okay.
So,
Clay volunteered, right?
Yeah, Clay, and if we can get any more on top of that, or just it's fine. So.
Okay.
Oh, so just tell me real quick before we disconnect here. So is there a way that I can practice or play with this, or to know how to screencast my screen versus camera and all that garbage? How do I do that?
Let's you and I. I'll make a meeting and we can just do that.
Okay. Okay. When did you want to do that, Carl? Doesn't matter to me.
I have a couple of work things that are going to tie me up in the next couple days, but I could do it maybe, I don't know, you want to do it Thursday afternoon or evening or something like that?
Yeah, that's fine. I'm easy. I'm here at home. We're not, we canceled most of our big parties, where we're having large quantities of people coming over to get infected. I'm curious, whether we got sick. I did a few days at the Perot Museum. It's sort of the Petri row. It's a great place for me to acquire infections. And it's funny, I was sick for a few days, and then Pam was sick for 2 weeks. So who knows what mystery illness we had? I assume it's just a good old cold. Boy, it proved to me how stupidly I could. I didn't take any precautions at the time. It was February 19th. Touched surfaces, touched my face like I like to do, and bang, we both got nailed. So it's proof that you can easily, contract a viral infection. Anyway, okay. So anyway, Carl, so we said Thursday.
I'll send you an invite for Thursday night, and we can redo this.
Okay, great. Appreciate that.
And I'll also include for anybody that wants. I'll include a link to the software I use to share my iPhone screen and camera.
Okay.
Because I don't know if you saw it, Ron, but it just does I think a pretty awesome job of webcam.
Yeah, so well, we'll get to it later. I was curious. You had 2 feeds I could see. For a while, I was just looking at your face, and then I realized, you know what? I think people are seeing more than your face. I was trying to look at the reflections in your corneas, you know, trying to see the screen, and then I realized, oh, I could click on that other panel and see the screen. Okay.
Yeah.
All right.
Well, good. Well, thanks for joining. All nice chatting with you. I hope you all stay safe. Keep your families and say, don't catch it, don't share it, and we'll all be good, right?
Yeah.
Cool.
Yeah.
Thanks for hosting.
Good night.
One quick question.
Oh, yeah?
Is the Uno any more durable than the Mega?
It's the same little regulator on it.
Okay. All right.
But what we, and if you want a separate one, Jack, we can maybe think about schematics or something, set something up. But there's got to be a way where, well, I think we talked about this once before. If we take and just list out the things you're trying to connect and power up, we can look at their specs, and then we can say, look, on this guy, you need to just feed it power from a separate place. Don't feed it power from the Arduino.
Okay. Yeah.
So,
all right. Thank you.
You wanna maybe jump in with Ron and I on Thursday night? Could that work?
Oh, sure.
And we could do screen share, get Ron up to speed with screen share, and then work together on your.
And I can give you a few bits of information on voltage regulators and loads and all that. Maybe.
All right. Thank you.
Not that I'm a wizard, but I do a lot of that crap. Anyway.
Okay.
We could probably figure it out if you don't mind, Ron.
Okay.
Yeah, we're good. Okay.
Good night, everybody.
Good night.
All right. Good night, guys.
Bye-bye.
Okay.